They say the Milky Way is our home, a sprawling, spiraling collection of stars, gas, dust, and dark matter that stretches across 100,000 light years. It cradles our solar system, shelters our fragile blue planet, and contains everything we've ever known. But what if we wanted to leave it? What if, one day, humanity decides that it's time to move on? Could we actually escape the gravity well of our galactic home and explore the cosmic ocean beyond? This is not just a fantasy of science fiction anymore. It's a question real scientists are beginning to ask, and astonishingly, there might be an answer. Like and subscribe to Beyond Stars for more mind-bending explorations like this one. First, let's understand just how bound we are to the Milky Way. Our galaxy is not just a cluster of stars in open space. It's a massive gravitational entity, an ancient structure made of hundreds of billions of stars, and an even more mysterious component: dark matter. Dark matter, which doesn't emit light or energy, holds the galaxy together like invisible glue. The Sun, along with all the planets including Earth, is orbiting the galactic center at roughly 828,000 kilometers per hour. Even at that speed, it takes our solar system about 225 million years to complete a single orbit around the Milky Way. We are trapped in this orbit, bound by the galaxy's gravitational pull. Escaping it would mean overcoming not just the pull of Earth, or even the Sun, but the entire mass of the galaxy itself. So how fast would we need to go? The escape velocity from the Milky Way, calculated from our position about 27,000 light years from the center, is estimated to be around 550 kilometers per second. That's almost 2 million kilometers per hour. For comparison, the fastest spacecraft we've ever launched, the Parker Solar Probe, travels at about 690,000 kilometers per hour, which is barely a third of what we'd need. To truly leave the Milky Way, we would need technology that is not just beyond our current capabilities, but perhaps bordering on the limits of physics as we understand them. Still, let's suppose for a moment that we had that capability. Let's imagine a future where propulsion is no longer chemical or even ion-based, but harnesses the raw power of antimatter, nuclear fusion, or even warp drives and Alcubierre bubbles, concepts that bend spacetime itself. In this future, humanity has found a way to push ships to relativistic speeds a significant fraction of the speed of light. That alone brings us to the edge of not just the galaxy, but the edges of time as we experience it. Traveling at those speeds would mean dealing with time dilation, where time slows down for the travelers but continues as normal for those left behind. A journey that might seem to take a few years for the crew aboard a near-light-speed vessel could equate to centuries or millennia back on Earth. If we did leave the Milky Way, it could be a one-way trip, not just physically, but temporally. But where would we even go? The space between galaxies is vast and mostly empty. The nearest major galaxy to us is Andromeda, sitting 2.5 million light-years away. Even at the speed of light, a ship would take 2.5 million years to get there, a practically unimaginable timescale. Even with hypothetical advanced propulsion, such a trip would still take many lifetimes, unless we developed some form of cryogenic stasis, generation ships, or AI-managed missions. Andromeda isn't the only option, of course. There are thousands of smaller satellite galaxies nearby, like the Large and Small Magellanic Clouds, but these are still hundreds of thousands of light-years away. Our galactic neighborhood, known as the Local Group, is about 10 million light-years across, and beyond that lies the Virgo supercluster, and then Laniakea, our larger cosmic home. Now, here's where it gets really interesting. The universe is expanding. That's something we've known for over a century, but recent observations have shown that this expansion is accelerating, driven by a mysterious force called dark energy. This means that, given enough time, distant galaxies will recede from us faster than the speed of light, not because they're moving through space, but because space itself is stretching. Eventually, only a handful of galaxies, those gravitationally bound to ours, will remain visible. Everything else will fade beyond the cosmic horizon. If we don't leave the Milky Way within a certain window of cosmic time, it may actually become physically impossible to ever reach another galaxy. matter how fast we travel, the universe will become an increasingly isolated place.